Good morning to everyone. Myself is Devi, Assistant Professor, Department of Artificial Intelligence and Data Science. I am going to teach the subject Data Structures using C++. Today we are going to discuss about the topic Shortest Path Algorithm. An algorithm to find the shortest distance path between the source and the destination vertex is called the shortest path algorithm. There are various types of shortest path algorithm, single source shortest path and all pair shortest path algorithm. In single source shortest path, the given input graph G equal to V, E and distinct vertex X, find the shortest path from S to every other vertex in G. S stands for the starting vertex and G stands for the graph. For example, Dijkstra's algorithm, it may be a weighted graph or unweighted graph. Second one, all pair shortest path problem. Given an input graph G equal to V, E, find the shortest path from each vertex to all other vertices in a graph. First, we will see about Dijkstra's algorithm. Consider a weighted graph. The general method to solve this single source shortest path problem is known as Dijkstra problem. It applied to weighted graph. The procedure for this solving this problem is it is use greedy technique. It produce proceed in stages. It selects a vertex B which has a smaller dv among all the vertices. Declare the shortest path from S to V is known. The remaining consists of updating the value of dw. Should set dw equal to dv plus cv. W if the new value of the dw would an improvement. Consider an example to find the shortest path for the following graph tracing the Dijkstra's algorithm starting at the vertex B. So here the start vertex is B. Consider this graph. We have to generate a table. The active vertices are A, B, C, D, E, F. Initially, except the start vertex, all other vertices distance is considered as infinity, which is unknown. We have to visit from a vertex start vertex to all other vertices. So always the distance of the start vertex is always 0. For all other vertices except the start vertex, it is considered as infinity. So here we are taken the start vertex as B. So from B we have to visit the all other vertices. So see from B we can visit A and C. So there is a path from there is an edge from B to A as well as B to C. The distance to travel from the cast is B to A is 3, B to C is 5. First stage for B to A is 3, B to C is 5. For all other vertices D, E, F, it is considered as infinity. And B, the start vertex, it is 0. A and C, 3 is the minimum value. So we are going to consider A as the next vertex. So from A we have to visit the all other vertices. So from A, there is only one edge to C. Its value is 1. So from start vertex we have to add B to A 3, then A to C 1. So 3 plus 1 4. So from B to C the cost is 4. Already we have visited A, then now we have visited C, so we have to visit from C to all other vertices. So there is edge from C to D and C to E. So C to E is 4 and C to D is 2. So the cost for C is already we have calculated, that is 4. So C to D is 4 plus 2 which is equal to 6 and C to E is 4 plus 4 which is equal to 8. So among 6 and 8, 6 is the minimum value. So we have to choose the vertex D. So from D we have to visit all the other vertices. All the remaining vertices, that is from D we can visit only F. So 6 plus 5, that is 11. So from we can visit from there is a path B to F. The cost to travel from B to F is 11, which is the new vertex. Its cost is 11. So after that the fifth stage is we have to choose E as the new vertex. So from E we have to visit other vertex. So from E we can visit only F. So from E to F there is an edge, its cast is 1. So the smallest value of E is 8. So 8 plus 1, which is equal to 9. So to visit from A to F, the cast is 9. This is how we can find the shortest from a start vertex to all other vertices. So the shortest path for each and every vertex is founded, and its presider, that is the previous vertex, is also specified here. So this is how we used to calculate the shortest path with the help of Dijkstra's algorithm. So we will see the advantages of shortest path algorithm, that is Dijkstra's algorithm. The advantages: finds the shortest path accuracy in weighted graph. It works efficiently for graph with non-negative weight. It can determine shortest path to all vertices from a single source. It is widely used in real-time routing and network applications. And the last advantage is simple and easy to implement using array or priority queue. So next we will see the disadvantages. It does not work correctly with negative edges weights, because becomes slower for very large graph without optimized data structure. And the third disadvantage is it requires more memory for sorting distance and visited nodes. And fourth one is complexity increases when the graph is dense. And fifth disadvantage is it cannot handle graph with negative cycle. We will see the applications one by one. Network routing protocol in computer network, and the second application is GPS and map navigation system for shortest route finding. The third application is airline and railway route optimization. Fourth is it is used in robot path finding in artificial intelligence. Fifth one is social network application for connection analysis. The sixth one is telecommunication and internet packet routing. This is all about the Dijkstra's algorithm in shortest path Dijkstra's problem in shortest path algorithm. Next we will see the next topic in the next section. Thank you.